Problem 21. For this problem, to get the area of triangle KBC, we will first calculate the length of BK and BC, and then we calculate the angle KBC to determine the area. Because ABJI is a square, therefore JB equals square root of 18. It equals 3 square root of 2. And similarly, for F, E, H, G, F, it's also a square. Therefore, EF equals square root of 32, and that equals 4 multiplied square root of 2. Because ABCDEF is equiangular, therefore BC equals EF equals 4 times square root of 2. And because triangle JBK is equilateral, and KB equals JB equals 3 square root of 2. And now let's calculate angle KBC. It equals 360 degree subtract angle JBK subtract angle JBA subtract angle ABC, and it equals 360 subtract angle JBK is 60 degree and angle JBA is 90 degree, and angle ABC is 120 degree, and it equals 90 degree. Therefore, triangle KBC is a right triangle, and its area is KBC equals 1/2 BC multiply KB. It equals 1/2 multiply 4 square root of 2 multiply 3 square root of 2, and it equals 12. So the answer is C. Problem 22. Because the group of students stands with different number of students in each row for 12 consecutive days, therefore, the smallest possible number of the students in a group should have exactly 12 factors, and it's also a common multiple of 15 and 6. Now let's consider the smallest common multiple of 15 and 6. It's 30. And the factor of 30 is 1 multiply 30, or 2 multiply 15, or 3 multiply 10, or 5 multiply 6. We can see that for 30, it has a total number of factors. The total number of factors for 30 is 8. So it's less than 12. Now let's go to the next common multiple. That's 60. And 60 has factors 1 multiply 60, and 2 multiply 30, 3 multiply 20, 4 multiply 15, 5 multiply 12, 6 multiply 10. Now it has exactly 12 number of factors. Therefore, the answer should be C. Problem 23. For this problem, because A, B, C, D, E will end up with 5 integers, and these integers are consecutive. Therefore, C must be the mean of these 5 numbers. Let's first calculate the value of C. It would be the sum of all the numbers, 2 plus 2 plus 2 plus 2.5 plus 2.5 plus 3 plus 3 plus 3 plus 3 plus 3.5 plus 4 plus 4.5 divide 5 for the 5 letters, and that is 7. Therefore, C has a value of 7. Let's write down A, B, C, D, E, and C is 7, then B is 6, A is 5, D is 8, E is 9. The problem states that 2 goes into cup E and 3 goes into cup B. Therefore, 3.5 cannot be in cup B because there's 6 minus 3 only equals 3. And also, if 3.5 is in A, then it's left with 1.5, and that's less than 2. So this cannot happen either. Then if 3.5 is in C, then it's left with 3.5. There's only one 3.5, so there has to be, and the smallest number given is 2. So if there's 3.5 and there has to be another 2, and there has to be another 1.5. So that's not right either. And for E, there's already 2. So it's like we are making up number 7 in cup C. It's the same problem. So the only one left that's possible is D. 3.5 has to be in here. So the answer is D. Problem 24. The baseball league is consisted of 2 4-team divisions. Each team plays every other team in its division n games, so that's a total of 3 n games. And each team plays every team in the other division m games, so that's 4 m games in total. And each team plays 76 game schedule. So because m is larger than 4, so let's assume m equals 5. Then we will have 3n equals 67 subtract 4m, and that's 67 subtract 4 multiply 5, 20 equals 56. And in this case, n equals 56 divide 3, and n is not an integer in this case. So this is not a valid solution. If m equals 6, similarly we will get 3n equals 76 subtract 4 multiply 6 equals 52. And n equals 52 over 3 Again, it's not an integer, so this is not a valid answer either. If m equals 7, then 3n equals 67, subtract 4, multiply 7 equals 48. And in this case, n equals 16. And the problem says n should be larger than 2m, and 2m in this case is 14. n equals 16 is larger than 14. So this is a valid answer, and the total game a team play within its own division is 3n, and it equals 48 games. So the answer is B. Problem 25. For this problem, we can easily see that there is a center square with side length 3 here. And what we need to think about is to see if there is any other square that is larger than the center square. And one possibility is that if the square goes through the corner of the shaded area, like this. So if the light blue square is true, then it covers the center square and it's larger than the area of the center square. Now let's assume this is this larger square is A, B, C, D, and this corner is E, F, G, H. Let's assume the length of AG is X. Then HA will equal to 3 subtract X. This is 3 subtract X. And if square ABCD is a valid square, then these triangles are right triangles. And here, angle EAF is also a right angle. Therefore, we can have that EA square equals HE square plus HA square, and FA square equals AG square plus GF square, and EF square equals EA square plus FA square. And we substitute these two equations into here, we get it equals HE square plus HA square plus AG square plus GF square. So now let's put the value of EF. EF is 3. Therefore, we will have 3 square equals here EA HE is 1, So that's 1 square plus HA is 3 subtract x squared plus AG is x squared plus GF is 1 square. So we simplify this equation, we get it's x squared subtract 3x plus 1 equals 0. And we can further simplify this. It's x subtract 3 over 2 square equals 5 over 4. That means x equals 3 over 2 plus or minus square root of 5 over 2. Now, so when x equals any of these two numbers, we do have a square that in this light blue ABCD that's larger than the center square and should be the answer we are looking for. And to calculate the area of ABCD, we actually have a simpler way, because when we put a vertical line from A to EF, the height of AEF is 1. So the area of AEF equals 1/2 EF multiplies height, that's 1, and it equals 3 over 2. And we have 4 such triangles. This one, this one, this one, this one. And we use 4 multiply the area of AEF plus this center square plus the area of the center square here. That's 3 square. It equals 4 multiply 3 over 2 plus 3 square equals 15. Therefore, the area of the square, the largest square that can fit into the remaining space, is 15.